Hello Internet, welcome to week 3 of Intro to Linux and Python. In week 1 we learned about the history of the GNU and Linux projects, where Linux came from. In week 2 we got situated on the command line, started to learn a few commands, and learned about going up and down through the file tree. So let's begin with some review, and then today we're going to be learning a bunch more commands that deal specifically with files. We're going to learn how to create and modify and remove files. This will give us a good grasp on how to use commands in Linux, which are how we get just about everything done. So let's get started. So I'm going to open up a secure shell, just like we've been doing. And you'll get this, and this is the IP address. Make sure that when you log into secure shell, you have your username, your first initial, last name, and the same IP address or host name of the server. So hit enter, and now I'm logging in. Remember that when you log in, it doesn't actually show you what you're typing as a security measure. So I will type in my password here, and there we go. I'm logged into the server. Notice it gives us all that information about our server right now, the memory usage, swap usage, number of processes, how many people are logged in, stuff like that. So right over here is our command prompt, which we talked about, which tells us information like our username, who's logged in, to the shell session, which server we're logged into, in this case CWK Rancho, and it tells us where exactly on the file system we are. Right now we're inside of tilde, which is my home directory, and it tells us whether or not we're a super user, with the $sign here implies that I am not. So let's review what we talked about last time. So we learned how to navigate between directories. So we use the change directory or cd command in order to change directories. So if I want to go to the root directory, which is / I do cd /. Now with cd, you can give it either a relative or an absolute path. An absolute path is a full path to a file or directory that starts at the root and then goes to every place that you need to go. So if I want to go to, for example, /home/azahid, my home directory, to go there with an absolute path, I type in cd and then everything from the root. So /home/azahid. And now I'm at my tilde or home directory. Now, the other way I could have done this was if I start at my root directory, I could see what's inside of it using the ls or the list command, like so. I can choose where to go next. So a relative path says where to go from here, whereas an absolute path tells you how to get somewhere with the complete path starting at the root directory and then telling you where to go. So I could do cd home, ls again, and then cd azahid, and we're at the home directory. So that's how to go down the file tree or to go to a specific place in the file tree. Now let's say that I'm inside of my home directory and I want to go up a level in the file tree. I don't want to go into a folder, I actually want to go out of this folder. To do that, we do cd ... So ... means you're going up. So let's say I go into some folder, let's say I'm in my root directory. I go into, let's say I go into root, or no, I can't because I'm not root. Let's say I go into bin. Well, there's a lot of stuff there. And let's say I want to go back to root. I can do cd ... and now I am back to the root directory. So that's how we use ... to go up the file tree. Okay, so now we know, and we've reviewed how to go into a folder and then come out of a folder. Next, we're going to learn how to create a directory. Now, before we do that, we might notice that there are a lot of files here, and ls on its own just gives us a name for every file. So it lists out the names of these files, and it color codes them, which is useful. But what if we want more information? Now, with just about every command that we're going to be using in Linux, there are almost always ways to modify that command or give the command special options to make it do more specific things. Now, for example, what if I want a list with more information? I want a list with, let's say, the file sizes as well, because we can't just see that or right-click and click on properties like we might do inside of Windows. So to do special things with commands, we've got to figure out what options they have. Now, there are a bunch of ways to do this. A lot of times commands will come with built-in help, where you might type in a flags at the end, like slash something. So sometimes there might be commands where you can type in cd -- help or something, and notice that the change directory, it gives us some usage here. Or with ls, I can do -- help, and notice that it gives me all the help information here. So it tells us all the different options you can use and what each option does, etc. Some commands use -h instead of help. Some commands want you to just type in help. So depending on the command, there's usually some way to get help. Now, there's actually a separate command that you can use to look at the manual page for a certain command, which will sort of list out everything like specific usages and examples and whatnot. So to do that, we have a command called man, which stands for manual, so man. So let's say I want to look up the manual about the ls command. I can say man ls. And now notice, unlike just typing in -- help, we actually go to a different application altogether. So man is a program on its own. It's not just giving us help, we're actually opening the man program. And now here we can see that we're on the manual page 1 for the list command. It gives us the name, a synopsis on how we use it. So we say ls, then we give it some options, then we give it the name of a file that we want to, or files that we want to see. And if we scroll down here, use up and down to scroll up and down, we see all the options. So let's say I want more information about a directory. So it seems like -l gives me a long listing format. So let's try that out. So I'm going to hit Q to quit, like it says down here. I'm going to say ls-l. And now notice that, and I'm running this from the root directory. Notice that this gives us much more information. Now, instead of just having the names, we now have the names. If it's a directory, there's a D at the beginning of the string here. There's whether there's read, write, and executable access for different levels. So RWX, R, no WX, R, no WX. So, and then we have which user created it, and stuff like that. We have the date that it was either modified or created, and whether it's linked to somewhere else. So there's a lot of information that it gives us here. We're not going to go into depth about that, but keep in mind that if you run across a command that you want to learn more about, or that you're confused about using, you can always look up the command in the manual by using the man command. All right, so now that we know how to go up and down the file tree, how do we create a directory? So I'm going to go into my home folder, which I can do by doing cd tilde. So that's a shortcut to get home. And now I'm going to make a new directory. So if I do an ls here, notice that there's a maze there, which you guys will see soon, but we'll talk about that later. If I want to make a new directory, the command for that is mkdir, or make directory. And then we give a space, and then as an option, we give it the name of that directory. So I'm going to call this testdir, or just a directory to test out, so test directory. Hit enter. And if I do a list again, notice that testdir appears. And it's like any other directory in Linux, so we can use cd testdir, and now we're inside the directory, cd ... and now we're outside of it again. Let's make one or two more just to test. So it's cd, or rather mkdir tester2, mkdir tester3, ls. So there's really nothing to it. So mkdir, name the folder, and you can make a directory. There are obviously options to this. So if I type in man mkdir, notice all the options for modes, whether you want to print a message for each directory. So most commands have some kind of options that let you get more specific with them. But a lot of them are, for the most part, straightforward. So now that we have that, now we know how to create directories. The next thing is creating files. In Linux, being able to manipulate files is very important. This is because Linux handles a lot of things with text files. In Windows, if we wanted to, for example, change our Wi-Fi settings, we might go and click on the Wi-Fi button and then click on a settings button and then change things with drop-down menus, or click and point and click. However, in Linux, or when we're running Linux from a shell like this, we don't have that luxury of being able to click on things and set options. So to overcome that, what we do is we basically have text files that have all of the options listed in them in a specific order that the application knows how to understand. So Linux probably looks for a configuration file for the Wi-Fi. And if you want to change your Wi-Fi configuration, all you would have to do is open that file, change what it says, and then save it. And that way you've changed settings. In fact, with most settings and most buttons you'll click, even if you're running a graphical type of Linux like Ubuntu with GNOME, all that clicking something often does is either run a command or change what's written in a text file by running a command. So it's important, very important, that we learn how to manipulate text files if we want to efficiently use Linux. So what we're going to do is the simplest way to create a text file, not to put anything in it, but just to tell Linux that imagine that there's a text file here. There's a command called touch. So the touch command just updates a file. So if you want to make it seem like you've done something to a file or make it, last modified date to be right now, you can touch the file. If you touch a file that doesn't exist, it'll create it. So inside of my home folder, I'm going to go into tester. There's nothing there, but I'm going to touch test file. And now in Linux, you don't have to give every file an extension. Most of the time, I'll be giving them .txt extensions just so we can be sure that they are text files and you know that. But if I just hit enter right now, it would create a file called test file, not test file dot anything. So I'll just do .txt. Now if I list it out, there's our test file.txt. All right, so that's how we touch a file, and if it's not there, it gets created. Now, how do we actually put text inside of a file? Or how do we create a new file with text inside of it? If you remember before, we used the echo command in class. So if we typed in something like echo hello world and hit enter, it would say hello world right back to us. Now, this seems really simple, and for the most part it is, but it's very useful for us to take a look at what exactly it's doing. Now, in Linux, we have this concept of streams or data streams. Now, a stream is data moving from one place to another, or data coming in from somewhere or leaving out to somewhere. Now, think about a streaming video like on YouTube. What's happening is that data is coming out from YouTube servers, and your computer is receiving that data, and it's going out from your computer onto your display so that you can see it. Now, similarly, we work with streams in a Linux file system. There are actually three standard streams. The first one is standard input. This is the default place that Linux will look for input. In our case, it's the keyboard. That's where if a program is looking for input, it'll probably look first inside or look from your keyboard. Second place is the standard output. So if an application or a command wants to print something or send something out to the user or out to be seen by something else, that goes to the standard output stream. Now, when we're using the shell, when we're using a command line interface, that standard output is usually printing lines to your console. So whenever we see something as a response or whenever we see something printed, that's because an application or a command sent something to standard output. So standard input is you typing, standard output is coming onto your screen so that you can read it. So a command like echo, all it does is it takes data from the standard input and then just takes that same data and sends it out standard output. Now the third data stream is the standard error stream. We won't talk about this too much, but basically if an application is running and it wants to, let's say, keep a log or write out what errors it's facing in the background without actually having to print that out here, some applications keep a log file so that they can write down anything that happens, and sometimes that gets sent to the standard error stream. And oftentimes the standard error stream directs to a log file on your file system. So those are the three streams. Now, how is that useful to us? Now, we're going to use that because in order to make a new file, one way to do that is to take a program that would send data to the standard output stream, but instead of letting it get to the output, we're going to redirect it into a file. So data comes in somewhere, but instead of going to standard output, we're going to make it go into a file and store it there. So instead of seeing it, it'll be stored to a file. So here's how we do that. We use the redirection operator. So that's basically just the greater than sign. So when you see a greater than sign in a long command or in a script or something, that means that we're redirecting to a different output stream. So what we're going to do is we're going to use echo. We're going to give it some text. So this is something that I am saying right now. And if we hit enter right now, it would take this from standard input, which I just typed in, redirect it to standard output. But what we're going to do is we're going to redirect it to a file. So I'm going to call this mytext.txt. So echo, that command runs, it generates some output, but instead of that output coming to me, it's going to be redirected to my text. So hit enter, ls, and there we go. We see that we have mytext.txt and the earlier test file.txt. So that is how you take a line of text and you store it in a file. You can echo it and then redirect the output of the echo command to a text file. However, we can't quite read what's inside of the file. So we need some way to look at the file or look inside of the file. Now, the easiest way to do that on the command line is by using a command called cat, C-A-T. So let's do cat mytext. And notice what happened there. I just typed in M and I hit tab. What that does is it uses autocomplete, which is built into the bash shell. So if I have multiple files starting with M, it would give me a list of those files. And if I only have one file starting with M, it would fill it in for me. So that makes typing commands really easy, especially when you have really long file names or directory names. So cat mytext. There we go. So that's what we stored inside of cat. So we have that line of text stored inside of mytext.txt. So that is how we can create a file that has text inside of it. So we can use the echo command and redirect it. But let's say that I want a file with multiple lines of text. So let's say I have, I'm going to echo, this is line number 1. I'm going to make that line1.txt. And then I'm going to say echo, this is line number 2. It is another line. Output that to line2.txt. So now I've got line1.txt and line2.txt. Let's say I don't want these to be separate files. I want them to be one file. Now, that's actually what the cat command is used for. So what cat does is it's actually short for concatenate, which means to take two strings of text and just mush them together. So what cat does is as options. It takes all of those files, merges their contents together, and then sends that entire sort of glob of text to standard output. So if we want to put line 1 and line 2 into the same file, one way to do that is by saying cat line1.txt, line2.txt, and notice that in our output we see those two lines being printed one after another. So if we just take that same command and output it to, let's say, 2lines.txt, ls, and now we see 2lines.txt. Let's open that with cat 2lines.txt, and now see inside of that text file we've got 2 lines. So that's how we can take lines of text or take multiple files and then merge them together into one file. That again is pretty inefficient if we want to use or if we want to make a file with a lot of lines in it. But here's an easier way. We can use a text editing program, kind of like Notepad. There's one built into the version of Linux we're using called Nano. So if we just type in Nano, it opens up an application called GNU Nano. This is 2.2.6. So Nano is part of the GNU project. It's one of those applications. So here we can just start typing stuff in. We can hit enter to get to the next line. And then we can actually use the up, down, left, and right arrow keys to navigate through the file. And we can erase it. So it's just like a good old-fashioned Notepad application. And notice how it takes over the entire screen. So it's not just running on the command line, it's actually taking over the screen. So standard input is going to here, and then it's printing stuff out as we need it. So once we're done typing stuff into here, I might type in that and maybe some numbers. 1, 2, 3, 4, 5, 6, 7, and 8. So the numbers from 1 to 10. So to save this, we notice that at the bottom there are these shortcut help keys here. It says what to type for doing what. This caret represents the control key. So to write out, we do Control O. So Control O, write out. So the file named write, I'm just going to call this numbers.txt. And then to exit, we just do Control X. So if we use ls now, notice we have numbers.txt right there. So now we know how to create files. Let's take a really quick look at how to delete them. So if I wanted to delete a file, I can use the remove command, or rm. Let's say testfile.txt. And there we go. Now test file is gone. However, if I wanted to delete a directory, I have to give it an option. So if I go back to my home directory, let's say I wanted to delete testdir3. So if I try to rm testdir3, notice it says I can't because it's a directory. To get around this, if it's an empty directory, you can say rm-d to delete an empty directory. However, if there is stuff inside of that directory, so basically there's a branch of the file tree, and under that there's a bunch of other stuff. If we only delete the directory, now there's a bunch of files not connected to our tree. So what we do is we actually delete that folder and everything inside of it, which is fairly intuitive. To do this, we use the -r, or recursive command. So if I do rm-r testdir2, not a problem. And if I ls, notice testdir2 is missing. And if I wanted to delete testdir and everything inside of it, I would do rm-r on testdir, but we're not going to do that. So let's cd back into testdir. And now that I've got this numbers.txt file, so let's cat numbers.txt, I've got a bunch of lines here. It might be the case that I want to see which lines contain a certain string, or I want to search through the text file. This might be true if we have a really long log file, or something like an agenda, and we want to find lines with dates on them. So there's a command called grep. So if we do man grep, notice that you use grep, you give it some options, and then you give it a pattern that you're looking for. This pattern can be just some words or some letters, or with a language called regex, or regular expressions, you can give it really specific patterns, like I want something with a number, a slash, 2 numbers, a slash, and then 4 numbers, like a date. So you can look for very specific patterns, or you can just look for text inside of a file. Let's take a look at how to use this. So let's say I want grep to give me every line in numbers.txt. So every line inside of here that has a T in it. So that would be 2, 3, 8, 10. So I can say grep, then the pattern, which in this case is just the letter T, and then the file, which is numbers.txt. I hit enter. There we go. So it gives me all the lines that match, which have that T in them, one by one by one. So if I wanted to, I could save the results of this search into a file. I could just do grep t numbers and then save that to results.txt. And then I can cat results.txt, and ta-da, there's all the stuff that we filtered saved into one place. So that's how we search through a file. You can be really, really specific with grep if you wanted to, so feel free to look into the documentation to see how to do that. Now that we know how to open files and we know a few commands, the next thing we're going to learn is how to put these commands together. In Linux, each command does a small task. We don't have one big program that does everything. Instead, we have small programs or small commands that do really specific things. Now, to do more complicated things, we could run commands one after another, or we can chain these commands together. Now, when we chain a command, what we're saying is that the output of one command, instead of going to standard output, we're going to redirect that output to another command. So for example, we might want to echo something, but instead of that echo coming back to us, we want that echo to go as the input to grep. Or we could concatenate 2 files and then search through them using grep. So let's try doing that. So let's say we concatenate, so let's see what files we have. We have my text, so cat my text, and we have numbers, so let's cat my text with numbers. We get or cat, we'd get a really long file. And let's say that we want to search through that file. So we could save that into a new file and then use grep on it, but we could redirect this to the grep command with an option. So let's say I want to look for a t again, so I can do grep t. If I hit enter, notice that I didn't give grep a file to work off of. What happened was that this is a pipeline, right? So, or a filter when we put a bunch of these commands together. So cat took that input of those files, it generated some output. That output was used as the input for the grep command. And then grep sent that output back to me. So that's how we can chain things together. I'll show you a really fun command called cowsay. So cowsay is like echo, but instead of just echoing things back, it makes a cow out of letters, and then the cow is saying things, so it's a cow saying things. So really easily we can echo things like hello, and then we can use the pipe to redirect that hello into cowsay. So instead of having to give output into cowsay, we just use the output from the echo command. We can do this with just about any command, and then pipe them together. And so that's how piping commands together works in Linux, and it's really useful. So that's about it. So we've learned how to navigate through the file tree, how to make files and directories and how to remove them, how to edit them, how to search through them, and now how to pipe commands together. We're going to be doing a lot of stuff with text files because that's how Linux stores everything. So make sure that you know your way around the Linux file system. And that's about it. Thanks for watching. Hope you guys learned something. Take care.